Hey class, if you made it here, you are in Unit 2.1. Congratulations, you made it past Unit 1. Alright, we're going to start off with something you know how to do. Y equals 2x minus 4. I want you to find out what y is. For x equals negative 3, you're just going to plug negative 3 in for x. 2 times negative 3 minus 4, and you get negative 6 minus 4, and you get negative 10. And you should be bringing that y down every single time. Y equals negative 10. So that's something that's really basic, and you know how to do that. So we're going to do something called function notation that takes what we just did just a little step further. And although you may be really used to this, function notation does have an advantage, and you'll see in just a minute. Alright, function notation. Y equals f of x is read. Y equals f of x. Ooh, I should have a little bouncy ball here. Y equals f of x is read. Y equals f of x. So when students read this for the first time, maybe they say, oh, I got to multiply f times x. No, that's not what is going on. This is the name of the function. My name is f. My input is x, and my output, y, is f of x. So input is x. Oh, that's really bad. Let's try that again. Input is x. Output, usually y. But this time we're going to replace that with f of x. And once again, the name of the function is x. Name is f. Name of the function is f. Okay, so here's some basic examples. Here's a point with the coordinates x is 5, y is 7. But we are going to say f of 7 is equal to 5. Pen's very glitchy tonight. And this one, f of 0. Alright, so down here we got some basic examples we're going to cover. Here's a point. It's got an x coordinate of y and a y coordinate of 7, and we are going to take that and we're going to put it in function notation. That would be f of x equals, and f of x. X is 5, so we're going to put the 5 right there, and f of x equals, well, y is like your output, f of x is like your output, so f of x is like y. Y is 7. So here's the advantage that I was talking about on that last slide. When you see f of 5 equals 7, you get to look at this one little sentence and say, hey, when x is 5, y is 7. It's the same thing as seeing the point 5, 7. Okay, if go back to that last slide, when you see y equals negative 10, and you see that as an answer, you're like, oh, that's cool, y equals negative 10, but what's that for? Oh, that's when x equals negative 3. You'd have to put two little bits of information together to see that that had, its x point, or its x value and its y value together. So function notation has an advantage. You get to see the input and the output all at the same time. So here's a second one, and that would be f of 0, x is 0, equals negative 5. Your output is negative 5. That's like your y, that is like your x. There, where your x goes, there's where your y goes. Now we see f of 6 equals negative 10. What do I want you to do with that? Well, if you were to guess, we're just going to like flip-flop this. Turn this into a point. So that is your x value, and that is your y value. So this is like the point 6, negative 10. Now, if I'm, these are questions on a test. There's no instructions here. You have to listen to me and figure out what I'm talking about. This one, x is negative 2, and y is 12. Look at this. This guy is not named f. This guy is named g. G of negative 2. That's perfectly okay. Functions have different names. Sometimes we have two functions we want to look at one time. We can't call them all f. Find f of negative 4 for f of x equals negative x minus 7. So we're going to take this negative 4 right here. That is my x. We're going to plug it in right there. Put parentheses around that x. On the outside of that, there is a negative. So this is going to say f of negative 4 equals, bring down that negative and then plug in negative 4 minus 7. We have the negative on the outside, the negative on the inside from the input. The opposite of negative 4 is 4. Minus 7 is negative 3. And let's bring down that f of negative 4. F of negative 4 equals negative 3. If we were going to graph that, we know that is the point, negative 4, negative 3. This is my answer. This is just an alternate way of seeing that. Okay, example 1, h of a equals 2a cubed minus 2a. And for this one, I want you to find, one second here. And for this one, I want you to find h of, why won't you write? So for example number 1, there isn't a real question here until I give it to you right now. I want you to find h of negative 3. Negative 3. So the a is negative 3, so we're going to plug that a in right here. We're going to cube it, put parentheses around where that a is. Minus 2 times, again, parentheses. I need those parentheses when I have an input that's got a negative. Going to keep you from making mistakes. So I'm going to take the negative 3 and cube it. Negative 3 times negative 3 is negative 9. Excuse me. Negative 3 times negative 3 is 9. Times another negative 3 is negative 27. So 2 times negative 27 is going to be positive 54. And then minus a negative, minus a negative. Okay, it's going to be positive plus 6. Plus 6. Oh, 1 second here. This says a positive 2 times a negative 27. That's a negative 54 plus 6. Negative 54 plus 6 is going to be like negative, or like excuse me. It's going to be like 54 minus 6, but then, put a negative in front of it. So it is going to be negative 48. So h of negative 3 equals negative 48. In example 2, I want you to find g of 8. Find g of 8. So g of 8 is equal to 3 times the square root of 2 times 8. Take the product inside of the square root first. 3 times the square root of 16. The square root of 16 is 4. 3 times 4 gives you 12. Bring down the g of 8. G of 8 equals 12. In example 3, I have a of x equals the absolute value of x. Remember that the absolute value is distance from 0 on the number line. And, well, if you are going to evaluate the absolute value of negative, it'll be positive. The absolute value of 0 is 0. So you're going to make a table of values, try to think of some good inputs. One of the easiest ones is 0. The absolute value of 0 is 0. Or put in 1. The absolute value of that is 1. Put in 2 and you get out 2. 3 and you get out 3. Let's plot those points now. 0, 0. 1, 1. 2, 2. And 3, 3. So we see a line going off in this direction. Let's plot it. Looks something like this. and it's going through 1, 1, 2, 2, 3, 3, 4, 4, etc. However, if you didn't think to put in any negative values, you wouldn't see what is the most interesting about this graph. You plug in -1, the absolute value of 1 is +1. Plug in -2, and the absolute value is 2. Plug in -3, and the absolute value is 3. Now you get these points over here. -1, +1, -2, +2, -3, +3, and you see that your graph looks like a line. Let's plot the other half of this. There we go. We got a V-shaped graph. Put arrows at the end here, show it goes infinitely far. Okay. There's more. This time I'm going to tell you that f of x is 22. I haven't done something like this yet. F of x is 22, and I want you to see what you can make of that. So you're going to take the f of x that's on this side of the equation, and you're going to put a 22. Bring down everything that is on the right side. So what are you going to do with this? You're going to find out what x is. So we have these denominators, 3 and 4. You remember what to do with that. You find the least common multiple of 3 and 4, and that will be 12. Here's my multiples of 3. 3, 6, 9, 12, 15, 18, and we can keep going. And for the 4, 4, 8, 12, and now we stop. We see that 12 is the least common multiple. So we are going to multiply 12 through the entire equation. So we multiply 12 times 22, and we get 264. We multiply 12 times 2x over 3. Remember, do the division first to make it smaller. 12 divided by 3 is 4. 4 times 2x is 8x. And then finally, 12 divided by 4 is 3. 3 times x is 3x. On the right side, you have like terms. You combine them. 11x equals 264. Divide both sides by 11, and we get x is equal to 24. So that means that f of 24 is equal to 22. F of 24 is equal to 22. So that's different. This time I gave you the output, and you had to see what the input was. You had to solve for x. Okay, I'm going to give you the problem right now. This is just part of the problem, and I'll give you some time to solve them. So for number 1, I want you to find f of 20. And for number 2, I want you to find h of n equals 11. So for both of these, I want you to work it until you can find an ordered pair. Now the ordered pair won't be your final answer, but before this ordered pair, you'll have found f of x equals y. So take a minute and see what you can do with those, and then unpause the video and see what you see. Okay, we're back. On the left, you just are going to plug in and evaluate, and then give your final answer. You're finding f of 20, so x is 20. 5 times 20 is 100, and the square root of 100 is 10. If you needed a calculator for that, there's another way to do this. You think what times itself equals 100. What if you square something and it's 100? What must that something have been? That's 10. 4 times 10 equals 40, so f of 20 equals 40. In number 2, this time you had the h of n given to you as 11. So you are going to put 11 in here and solve for n. You were given the output, you're solving for the input. So you're doing an algebraic equation. Subtract 3 from both sides, and you get 8 equals negative 4n. Divide both sides by negative 4, and you get negative 2 equals n. And then finally plug that negative 2 in right here, and you get h of negative 2 equals 11. Now you're done with the notes. Go on to do the practice exercises. And after those practice exercises, check your answers on Moodle.